Hello and welcome. I'm your host, Adam Hawkins. This episode is a small batch of software delivery education. If you enjoy this episode, then share it with your friends and colleagues. Hello, everybody. The work I've been doing recently has required me to jump around to a lot of different repositories and also create many new repositories. And that made me realize the importance of a good pre-commit hook. You had worked with some repositories that had automated testing built in there, code styling, linting, checking, all kinds of different static analysis. And that made my work much easier, especially as a first-time contributor to some of these repositories. But then also considering what it would be like for people who came after me to work on repositories that I just created. So I think that the pre-commit hook is a really important part of the continuous delivery workflow. Maybe it's something that everyone has not been introduced to, but I think that if you add the pre-commit hook to your workflow, it will change the way you work. So here's an episode on the pre-commit hook. The pre-commit hook is a powerful tool for increasing quality in the continuous delivery pipeline. The commit is the first step in the pipeline, so any work done at this stage has downstream ramifications. The hook provides developers with immediate feedback by blocking bad commits. So what constitutes a bad commit? Consider the question from a lean manufacturing perspective. One of the fundamental ideas in lean is assuring quality at the source. Now imagine an automobile assembly line. One step produces lug nuts. The next step uses the lug nuts to mount the wheels on the car. If the lug nuts are the wrong size, then the wheels cannot be mounted. The assembly line stops as a result. This is an outage. The assembly line may only resume after the lug nuts are produced correctly and handed off to the next step. There's a metric for this scenario. It's % complete, % accurate, also known as %CA. This metric measures quality in the value stream. The lug nut in the example was complete, but not accurate because it was not usable as is. Or in other words, it required rework. Checking quality at the source prevents these regressions, which could turn into full-blown outages. So what does % complete, % accurate mean for commits? It means the proposed changes are usable by downstream consumers. There are two downstream consumers for commits: the deployment pipeline and other engineers. Commits that knowingly fail the deployment pipeline should be rejected. Allowing these commits to proceed through the pipeline only creates waste. We've all been there waiting behind the build that takes too long, then fails on some dumb mistake like a typo or a malformed build configuration file. That build should never have even started. Running static analysis in the pre-commit hook easily prevents these regressions. Commits are also code reviewed. This requires that other people read and understand the code. Inconsistent style is jarring to code reviewers. It increases the time and effort to complete the code review. It also creates rework for the original authors. Just a few minutes here and there fixing this and that, then waiting for the builds and eventually getting to an approval. Again, this is just waste. These regressions are easily prevented by adding linting and formatting in the pre-commit hook. And then it's not possible to push commits containing known rework conditions. This is just static analysis and automated error correction. The key is automation. If this process is not automated, then simply put, it's not going to happen. After static analysis, run some tests. I say some because it's likely impractical to run the entire suite in the pre-commit hook. Instead, run the fastest tests, or the most frequently failed tests, or just the test associated with the file stage in that commit. The objective is to quickly fail known bad commits. In other words, fail fast. These practices will increase the quality of individual commits and provide developers fast feedback on correctness. Here's an outline for a pre-commit hook you can add to your projects. Step 1. Run static analysis on all file stage for the commit. Use tools like ESLint, shellcheck, Rubocop, YAMLlint, JSONlint, etc. Also use the autocorrect option to automatically make stylistic changes. Step 2. Run static analysis on all configuration file stage for the commit. I'm referring to files like your CircleCI YAML file or your Travis YAML file. These files are often read by the pipeline itself, so errors here would definitely break the pipeline. Validating them with the provided CLI prevents obvious regressions. Step 3. Auto-format code using tools like Prettier or GoFormat. Step 4. Run those tests. Now, any file stage in the commit should be caught by a linter or static analysis tool. If not, then the pre-commit hook should fail. This requires developers either update the linting configuration to handle the new file or explicitly ignore it. This ensures that files introduced to the codebase are covered by the pre-commit hook. When downstream failures occur in the deployment pipeline, consider preventing them by improving the pre-commit hook. Over time, the % complete, % accurate will increase. Feels good, right? That completes this batch. Visit smallbatches.fm to subscribe to the show for free. Would you like a topic covered on the show? Then call +1 833 933 1912 and leave your request in a voicemail. Hope to have you back again for the next episode. So until then, happy shipping. Want to learn more about DevOps without wasting your time? Then sign up for my free email course at freedevopscourse.com. My course combines the best from the DevOps Handbook, Accelerate, and years of software delivery experience. You'll learn the 3 ways of DevOps and the 4 KPIs of software delivery performance. More importantly, I'll show you how to put that theory into practice. That means shipping better software faster. Sign up today at freedevopscourse.com.